Hello, our video today is going to be a review of exponential rules. So these are exponent rules that you should have seen before. We are going to start off by reviewing the ones that you know, and then what we're going to do is we're going to end up applying those to some new numbers. So the first property is a to the m times a to the n. When you have the same base that you're multiplying, you are going to be adding the exponents. So when you multiply the same base, you add the exponents. The next one is a power to a power. When you're raising a power to another power, an exponent to an exponent, you are multiplying those two numbers together. Our next property is when we have a quantity raised to an exponent, what we have to do is we have to distribute that x into those parentheses, and you can only do this if it's all multiplication inside. See how it's a times b? If this was a plus b, we know that we would have to multiply out those quantities using our distributive property with FOIL. But when it's all multiplication, you just distribute the exponent to each of the individual pieces. Our next exponential rule is a to the 0. Anything to the 0 power, no matter what, is 1. No matter how big, how small, positive, negative, this whole quantity of a brought to the 0 power will be 1. So up here we multiplied like bases. When we look at the fraction, don't forget fractions mean division. So when I am dividing like bases, I'm going to subtract the exponents. So multiply like bases we add, dividing like bases we subtract. Just up here, how we distributed that exponent into the parentheses, I'm going to do the same thing when I have a fraction. I have to distribute the exponent to the numerator, and I have to distribute the exponent to the denominator. Our next exponential rule is negative exponents. So when you have a negative exponent, you are going to do the reciprocal. So we say you move it, you lose it. So I'm going to take the a, which is currently, if I make this into a fraction, it's a over 1. I'm going to move it to the bottom. I'm going to do the reciprocal. And when I move it, I lose that negative. So it becomes, instead of a to the negative m, it becomes a to the positive m. There's nothing left in the numerator, but we have to have that placeholder of a 1, because if I didn't have that 1, it wouldn't be a fraction. The last one here is there's two different ways you can approach it, because this one is actually applying two different properties. One property is the negative exponent. So what we just talked about, you can move it, you lose it. You do the reciprocal. So if I do the reciprocal here, I can end up with b over a, and then I make that a positive m. Since everything is getting that negative m exponent, I do the reciprocal of both pieces. And then I distribute to get b to the m over a to the m. That's one way. You also could have distributed first and gotten a to the negative m over b to the negative m, and then taking care of the negative by doing the reciprocal, giving us b to the m over a to the m. So it doesn't matter the order that you take care of the exponents, the different rules that you have. So those are our exponential rules. We're going to start off with some easy applications of those rules. And you can see in our directions, one of the key pieces is that we always want to make sure that we're rewriting with positive exponents. Because if you had negative exponents, you wouldn't have taken care of this rule up here of a to the negative m. So number 1, a to the 4th times a to the 3rd, I see that I'm multiplying like bases. When I multiply like bases, I'm going to add the exponents. And no, as you're sitting there thinking to yourself, you do not have to write out the 4 plus the 3. I'm writing it out so that you remember where it came from. So in your notes, if you're looking back at your notes, I'm like, oh, I remember. But in general terms, if on a quiz or test, if we were in the classroom, you do not have to show the 4 plus the 3. Number 2, we have a power to a power and we have to distribute. So that 3 has to go to the x and it has to go to the y. Just remember when there's no exponent written, it's really a 1, and you're multiplying. 1 times 3 gives us x to the third. 2 times 3 gives us y to the sixth. With number 3, we are dividing like bases. Important, because when we divide like bases, we are subtracting. I'm going to show you this in 2 different ways. So if I follow the rule from above, I would be doing 2 minus 10, which would give me a negative 8, but then I'd have to do the reciprocal and move it to the bottom to do it, then move it, you lose it, doing the reciprocal of that negative exponent. That's one way. The other way to think about this is the who wins rule. I have the same base. I know I'm going to subtract, but I look to see who's bigger. I've got a 2 and I've got a 10. Who wins? 10 wins. So instead of subtracting 2 minus 10, I know that the m is going to stay on the bottom because that's the bigger, and then I do 10 minus 2, which gives us 8 on the bottom. So wherever has the biggest exponent, that's where the base is going to stay. Moving on here. All right, number 4. Number 4 and number 5 are going to become very important. These are easier examples of a question that's going to be a little bit harder down the road. So the first thing that I notice in number 4 is that I have the same base. I'm always looking for something that they have in common so that I know how to put them together. I'm going to do the numerator first. I'm going to combine these 2 pieces. They have the same base, so I am adding those exponents. 5 plus 1. So that gives me 2 to the 6th all over 2 to the 4th. Notice how I didn't change the base. Just like I didn't change x's, the base stays the same. All I do is add those exponents. Now I see that I have, again, the same base. I have a base of 2. I play my who wins rule. The 6 is bigger than the 4, so I'm going to subtract 6 minus 4 to give us 2 squared. I'm going to make sure that I multiply that out. We know what 2 squared is. 2 squared is going to give us 4, so I'm going to evaluate that one. When I go to number 5, I'm always looking for something that's the same. And in number 5, I don't have the same base like I did in number 4, but I can rewrite the bases so that they are the same. 27 can be rewritten as 3 cubed. 9 can be rewritten as 3 squared. Now, you've got to be careful because this was 9 to the 4th power, so that becomes 3 squared to the 4th power. I just did a substitution. 9 got substituted out for 3 squared. So I'm going to keep on simplifying. I've got a power to a power, so I'm going to multiply 2 times 4 to give us 3 to the 8th, all over 3 squared. Now after that work, I end up in the same place I was in number 4. I see that I have the same base in the numerator. I'm going to combine those pieces. Multiplying the same base means I add 3 and 8 to get 11. And I have the same base on top and bottom. I'm going to subtract. Who wins? The top wins. So 11 minus 2 is going to give us 3 to the 9th. And don't forget, we didn't change the base once. All you're doing is adding or subtracting those exponents. And then if you were to get out your calculator and do 3 to the 9th power, it's not as bad as you think. It's 19,683. So when it's a reasonable number, and that is a reasonable number, you want to go ahead and write it out. Number 6, I look and I have x's in only one spot. I have y's in only one spot. I've got z's in only one spot. Okay, so I can't combine any of those pieces together. The only thing wrong with this one is that I have a negative for the y. And we want to be careful because only the y has a negative exponent. So the x is going to stay on top. The z is going to stay on top. You only move the base that had the negative exponent. So when we talk about reciprocal, it's only the reciprocal of the negative exponent piece. Okay. All right. Getting a little bit harder here. But number 7 is a little trick to it. All of a sudden I see that raised the 0 power. That means all of that is just going to be equal to 1, so it doesn't really even matter. When I look at these pieces, I do want to simplify what's inside first. So I see 18 over 24. That's just a fraction that simplifies down to 3/4. They both can be divided by 6. Then I see my x's. I have x to the 9th over x to the 5th. That's our who wins rule. The top is bigger. 9 minus 5 is going to leave us with 4 x's on the top. And that negative exponent, that y is going to move to the bottom, to the 5th power. So I need to distribute this to all of the pieces. Remember that 3 has an exponential value of 1, so this becomes 3. 1 times 5 is 5. 4 times 5 gives us x to the 20th. And then again, we distribute that 5 to the bottom as well. That becomes 4 to the 5th. 2 times 5 gives me y to the 10th. We multiply those numbers out. So 3 to the 5th is 243, x to the 20th on top. 4 to the 5th is 1024, y to the 10th on the bottom. Now there's lots of different ways that you could have simplified that. I like to simplify it first from the inside so that I have less complications as I start distributing my numbers. When I get to number 8, I can either take care of this negative first or I can take care of this negative first. If I see that I have negatives inside, I like to distribute first. But it's not wrong if you do it the other way. So that becomes 3 to the negative 4th. Remember that this is not 3 times a negative 4. It's 3 to the negative 4th power. And then a negative 2 times a negative 4 makes that a positive 8. That's why I like to leave it. And there's nothing going on with that second piece, so I just rewrite it. This is a negative exponent, so I'm going to move that to the bottom of the fraction where it becomes positive. I've got the coefficient of 2 on top. Here I'm multiplying y to the 8th times y to the 10th. I'm multiplying pieces with like bases, so I'm going to be adding those together, where I get y to the 18th. So I've got 2y to the 18th all over 81. Okay, our last one, we have 25, base of 25, base of 25. That's the same base, so I'm going to add those exponents together to get 25 to the 20th. But this one's a trick question because I've got to be careful. I can rewrite that base of 25 as 5 squared. Power to a power, 2 times 20 gives us 5 to the 40th. Now, if you were to do 5 to the 40th in your calculator, you're going to get quite a large number. So we're not going to multiply that out, and we're going to keep it as is. Okay, that is it for our exponential review.